day everyone. Before anything else, let me ask you a question. What if I told you that 88% of grade 7 Filipino students are not reading at grade level ready? Or that 40 to 52% of junior high school students are already 2 or more grade levels behind in reading? That's the reality in classrooms right now. And the tools teachers rely on traditional approach like Fletch Kincaid and Dale Shaw can only estimate how hard a text is. They can tell a teacher whether a student is actually improving. So the question we asked ourselves was simple. What if what if there was a system that didn't just measure a text but understood the student reading it? The question is what led us to build Talasa AI. I am Mark Nino Ritualo, the project manager,
I'm Lester Gomba, the lead developer.
and let me walk you through what we've built. Talasa AI is a web-based system that predicts the reading difficulty of grade 7 English passages and tracks student progress. But more than that, it is a system that finally gives teachers what they've never had: a clear and data-driven answer to which material is right for the student. Here's what that looks like in practice. Talasa AI classifies passages into easy, moderate, and difficult. It tracks students' comprehension, completion, and time spent. It recommends the next reading material based on real performance, and it reports all of that to teacher through a live dashboard. No more guesswork, no more one-size-fits reading list. Our target users are grade 7, working together with English teachers. And we're building this the right way through Agile Scrum, iterative 2 week sprints from discovery all the way to go live, which we're targeting for October 17, 2026. Let's move on to what we're committing to deliver. For goals, four goals, and every one of them is measurable. So first we classify we will classify grade 7 text into easy, moderate, and difficult. Second is we're holding ourselves to a real standard: strong accuracy and F1 score in our readability prediction model. Third, we track student performance, comprehension scores, task completion, and time spent, so progress is visible, not assumed. And fourth, last, we close the loop, guiding students toward their next reading level based on how they've actually been performing, not a fixed curriculum pace. Next is a problem and our solution. So let's go back to the numbers I opened with. So 88%. 88% of grade 7 Filipino students not reading grade level ready, and 40 to 52% already 2 or more grade levels behind. The Philippines also rank low among 64 countries in the PISA reading assessment. That's the scale of the problem we're addressing. As I mentioned, tools like French Kincaid and Dilsha, the traditional method or approach, only estimate how hard a text is. They don't track how a student is actually improving over time, so teachers are left without real insight. That's exactly where Talasa AI comes in. It is an NLP-powered classifier and progress tracker that automatically classifies passages into easy, moderate, or difficult, and tracks each student's comprehension, completion, and reading time, recommends the next best material for every learner, and gives teachers a live dashboard for data-driven decisions. Phases and milestones. So we will tackle the timeline of our system. So here's our proposed timeline broken down into five phases. We started with discovery. From June 22 to 30, the phase is already completed. The design. From July 1 to 8, also completed. We are now in sprints 1 through 5, running from July 9 to 21. This is currently ongoing. After that comes with deployment from September 22 to October 10, and finally go live from October 11 to 17, but they both are not yet started. So sprints 1 to 5 cover requirements definition, datasets construction, model training, system deployment, integration testing, and user feedback. We've built in buffer time ahead of deployment and go live to keep us on track. So next is completed study. Let's talk about what we've already accomplished. In discovery phase, from June 20 to 30, we gathered projects requirements from our stakeholders, conducted interviews with teachers and evaluators, and identified candidate datasets resource for training our model. In design phase, from July 1 to 8, we defined the system architecture and database schema, produced wireframes for key screens, and specified the algorithm we'll use for readability classification. Both phases are fully completed, and they gave us a solid foundation before development began. Next presenter is our lead developer, Mr. Lester Gomba.
Thanks, Nino. So that's the plan for keeping our classification accurate despite the challenges. But the plan is only worth something if there actual progress behind it. So let's shift gears for a second. How far along are we really? So first, the completed progress, which is sprint one. So let's start what were we actually right now. Sprint one is done. That ran from July 9 to July 23, and the entire sprint was dedicated to one thing: requirement definition. Now, I know requirements definition doesn't sound exciting, but stay with me because this is actually the sprint that protects everything else. This is where we lock in exactly what Telesa AI needs to do, how it needs to perform, how to secure it has to be, and what counts as success for this whole project. Basically, we made sure we weren't building on guesswork. Every feature coming after this, the dashboard, the assessment, the model, all of it traces back to something we already validated here. So sprint one wasn't just a checkbox, but it was us making sure the rest of the project doesn't fall apart later. Next is our current progress, Sprint 2, which bring us to right now. Sprint 2, running from July 24 to August 7, this is where things get real. So things are happening in this spiral. First is dataset construction. We're compiling and organizing grade level 7 English passages. This is the raw material. Without a good data here, nothing downstream works. So second is the model training. Alongside that, we're building in tuning our SVM classifier, which is the actual brain of Talasa AI. This is the part where it looks at the passage and decides, is this easy, moderate, or difficult for a grade 7 reader? If Sprint 1 was the blueprint, think of Sprint 2 as pouring the foundation and wiring the brain at the same time. This is the sprint where Talasay I stop being an idea on paper, but starts actually thinking. Next is the remaining test, the road to go to live. Okay, so what's left? Here's the honest roadmap, sprint by sprint. Sprint 3, system development that runs from August 8 to August 22, building the actual application around the model we're training right now. Next is Sprint 4, integration testing that starts from August 23 and ends with September 6, 2026. Make sure the login, the dashboard, model, and the database all talks each other properly under real conditions. Sprint 5 is where user feedback and revision. September 7 to September 21, putting this in front of real teachers and students and actually listening to what they say. Next is deployment. September 22 to October 10, rolling it out, training teachers and students to use it with confidence. Next is go live. October 11 to 17. The moment Talasa AI stops being a school project and starts being a tool that can actually uh, help students read better. 5 steps, one clear finish line, and we're not just planning to get there, we're already moving. Next presenter is Ninya Ritualo.
Challenges. Now let's be transparent, because that's exactly what a project like this deserves. Building a system that works in real classrooms means confronting real-world friction, and we've met four of them head-on. First, labeled datasets. Our passage currently lacks the difficulty levels needed to train the classification model. Second, validation. We don't yet have an English major validator to confirm those levels are accurate. Third, a pilot site. We're still securing a partner junior high school for testing and the data collection. Fourth is dataset volume. Locally sourced grades 7 English passages are limited. And none of these are signs the idea doesn't work. They're the exact problems you'd expect to face when you're building something that has to work in the real world, not just on paper. And we already have a plan for each one. So to tackle the strategies, let's call our lead developer, Mr. Gomba.
For the strategies, as Nina Ritual said, we'd be lying if we said everything goes smoothly. Every real project hits a roadblock. But what matters more is what you do about them. So what we're doing. First is search for a junior high school. A model is only good as the real student it's tested on. So we're actively reaching out to secure a partner school for piloting and data collection. Second is look up a dataset validator. We're not guessing at what count as easy or difficult. We're coordinating with English major faculty and Phil Erie trained evaluators. So every label in our system is backed with actual expertise. Third is ask for available local dataset. Instead of waiting around for data that doesn't exist yet, we're requesting a local source grade 7 passages directly from DepEd and school resources, data that's already relevant and ready to use. These aren't our backup plans. This is us protecting the credibility of the Lhasa AI before it touches a real classroom. Now for the modifications as discussed by Nino Ritualo.
Because of these challenges, we made one key modification to our approach, classifying passage difficulty. Here's what that means in practice. When we come across a passage where the given difficulty label doesn't actually match what the passage reads like, we don't just accept it. We step in, read and understand the passage ourselves, and adjust the difficulty classification based on our own assessment. It is a hands-on approach, but it's a necessary one. While we work on securing a dedicated English major validator, this lets us keep our dataset accurate and moving forward, because a model is only as good as the labels it learns from. This modification let us stay on schedule while still protecting the accuracy of our classification model. And to continue the diagram and prototype, let's call our lead developer, Lester Gomba.
Okay, so with all that context in mind, let's zoom on what the system itself actually looks like from the user side. Because a model can be accurate, a timeline can be on track, but none of it matters if the actual experience doesn't work for the people using it. We built Talas AI around two roles, student and teacher, and map out every interaction each one has with the system. So let's start with the student side. It begins when they open the app, which automatically includes login. So there's no separate to think about. From there, they go through a pre-assessment which includes joining their class, so they're placed correctly from day one. Once they're in, they land on their dashboard. This is where it extends into two things, the progress track and their profile, both accessible right from the same view. Then the core loop. They read a passage and which includes answering the assessment tied to it. Once they're done, they submit the assessment. And that's submission includes rating the difficulty themselves, giving us their own perspective on how the passage actually felt. And finally, they receive their score, closing the loop from reading to result. Now, on the teacher side, it's a shorter but more powerful set of actions. Teachers simply log in, separate from student flow entirely, since their dashboard and permission are completely different. From there, they can add a new passage to the system, and that action extends into adjusting the difficulty. So, a teacher isn't just uploading content, they're fine tuning how the system classifies it. They can also assign text to the students, view the student progress tracks across their class, and receive submittals as students complete their work. So here's the thing to take away. Every action a student takes eventually surface from on the teacher side. A submission, a progress track, a difficult rating, nothing disappears into black box. That's the blueprint behind everything you're about to see. So next is the prototype, which is the wireframe preview. Alright, let me actually show you what it's look like. During the design phase, we map out low fidelity wireframes for every core screen before writing a single line of production code. Let's walk through them. First is the login screen. As you can see, it has clean toggle between student and teacher, email and password fields, and a single login button. One entry, two completely different experiences waiting on the other side. For students, once they're in the dashboard, it greets them by name, like good morning, and then student name, and immediately shows that what matters, their current class level, their pre-assessment score, and how much their weekly reading they completed. Right below that, they're assigned for the week, so they never have to guess what's next. Then there's the passage screen. Their weekly reading queue, one passage at a time, tagged by difficulty. key and type with simple reading start button. No distraction. The next thing they need to do and their progress tracker. Current level, best score, latest score, and full trend line of their scores over the past weeks. This is where the student this is where a student or a teacher can actually see growth happening, not just guess it. Now flip to the teacher side. The teacher dashboard gives full view at a glance how many students are in easy, moderate, and difficult. Recent submissions coming in and a class-wide screen distribution. Everything a teacher needs to make a decision without digging through spreadsheets. To be clear, this is um, still an early stage prototype. The final UI will be refined as we move through Sprint 3. But what you're looking at right now already proves something important. Talasa AI isn't a concept anymore. It's a real world design, screen by screen, decision by decision. So that's for the development part. And
On behalf of our team, thank you for listening and your attention. Again, I am Martin Ritualo, our project manager,
I am Lester Gomba, the lead developer.
and we are Talasa AI.